The topic is, how do you set up your control zones, your hazard control zones? This came about because after some of the NFPA committee work, we were getting a lot of mixed signals from people. And so we thought it might be a good idea to actually have a session and just throw out some ideas, give people something to think about. And so Christina Baxter, Dr. Baxter is going to start it off. She's going to give an overview on control zones for a bit. And then we are going to run through 5 different scenarios and give each of the speakers 5 minutes to explain, how they would set up control zones for this particular type of incident. And then we'll have about 5 minutes or so, depending on the conversation, to discuss it amongst the 6 presenters, as well as I'll be monitoring on this computer to see if there's any questions or chats and bring people in for that. Make sense? Probably not, but that's what we're doing. All right, Christina Baxter, do you want to take control right now?
I am going to take control and go ahead and share the presentation. Let me know if it is showing up as full screen.
Yes, it is.
Okay, so as Rick said, in the recent updates to NFPA 470, which will consolidate NFPA 472, NFPA 1072, and NFPA 473, we were actually going through and talking a lot about different definitions and different things to make sure that across all of the different standards, we were using the same terms. And one of the issues came up, which was establishing control zones. And we went back and forth on the terminology specifically to start with. And there were so many different terminologies that it was just mass confusion. And then we started down the path, and it was Rick and I trying to ask people, well, how do you set your control zones? And everybody had a different answer. So what I'm going to try to do with this intro presentation is first talk about the different names and terms that we see, the requirements, and just a few examples of different ways that you can establish control zones. And then I'm going to turn it over to the guys and have them talk about different scenarios and what they would use and why. And it's really about the answer to all of it is there's no one way that's right. But the one thing that has to happen is clear communication of what control zones you're using and why. And so let's start out first with what are they? So in reality, control zones are just administrative areas. They're areas where we are focusing the hazards, where we can have the situation grow in size and shrink in size, and where we're trying to make sure we can minimize the risks to personnel and the community. So they also represent operational areas. And those operational areas have to protect the response personnel, minimize exposure of unprotected personnel, and prevent the accidental spread of hazmat and CBRN agents. So reality is here, when we set these areas, we need to communicate clearly exactly where those areas are and what the expectations are for within each area. So you can call it an area, you can call it a zone, you can call it a corridor, you can call it whatever you want to call it, as long as we clearly communicate what is acceptable behavior within each environment. And that acceptable behavior is generally going to say the types of work that are going to be performed, the types of PPE that's going to be worn, and are there any strict exclusion zones where the hazards are so high that nobody's going to go into there, regardless of what training or PPE they have. Now, one of the things that we have to keep in mind is that just like a risk assessment is dynamic, the zones that we build in our control zones have to be dynamic as well, because all of the different things that can affect your hazard assessment also affect your control zones. So whether that be topography or a container breach, or it's just regular atmospheric changes, all of those things are dynamic and have to be assessed throughout the entire system. So some of the nomenclature was causing great confusion. So we have to remember, and from an operational level responder, there's 2 different things that that person might do. That's prior to any of the hazmat teams being called. And that's setting an initial isolation zone and forming out protective action distances. That is guidance that comes directly from the Emergency Response Guidebook. It is expected that anybody at the awareness and operations levels knows how to find that information and that they implement that. But that is not to be confused with what will become the cold, warm, and hot zones in terms of a technician level response. So we're going to talk about these. And so I generally talk about the cold zone, the warm zone, and the hot zone. But I just put down below some of these other terms that are used. Sometimes the hot zone is called the exclusion zone, the dirty zone, the red zone, the dangerous zone, or the bronze zone, or I think it's, yeah, bronze zone. Now, when we start looking at the, for me, the warm zone, that's most often called either warm zone or contamination reduction corridor. But it's also called the yellow zone, the unsafe zone, and the silver zone. And so the other one, when we get to our support zone or our green zone, that's generally where we're saying that the level is such of the contamination that there's either nothing measurable there, or what is measurable is below some specific level that is considered to be safe to operations. Okay, so that's why some people call it a safe zone. Now, when we get to some of our other partners, they actually don't talk about the zones per se, but they talk about inner and outer cordons. And that inner cordon is generally the line between the hot zone and the warm zone, and the outer cordon is the warm zone to cold zone. So they have more of a line or cordon versus a zone. So what we need to make sure is that every time that you're working as a team, it's usually pretty easy because you've got these known zones, known nomenclature. But as you start bringing in responses that involve your neighbors, or where you're actually working together with a much larger event, that everybody's using the same terms and that they also are making sure that they have the same markings and meanings. So let's just go through and define what we're talking about here. When I say hot zone, I mean the area with the highest potential for exposure or contact with a hazardous material. Okay, that's the area where we are dictating that our personnel are going to do something and generally wear specific PPE to minimize their exposure in case they contact that material. The inner cordon is then the transition from the hot zone to the warm zone. For a warm zone, I'm really talking about that area where we're taking equipment in and out of the hot zone and we're going to decontaminate it. Equipment personnel. I may have an equipment staging area in the warm zone where it just sits there and goes back in with the next entry team. If it comes out of that space where it's sitting out to the cold zone, then it gets decontaminated. And so there's different things that go on in these different zones. But the real issue with the warm zone is generally a place where you have the access control points. It's where you keep track of who's going in and out of a contamination level, and you're minimizing that spread from the hot zone out further. And then, of course, the cold zone, that's where all of our support functions happen. But that's where the contamination levels are below levels of concern or at acceptable levels. So one of the things that we have to remember is that if we can't measure these, then we may have to go with different areas and always erring on the side of safety. Most importantly, it's about visually indicating where those zones are so that everybody can see it. Visually indicating it can be as simple as, okay, we're going to say the hot zone is everything inside the building. The warm zone is the door area where we're going to come in and out. And the cold zone is everything past decon. Simple. But what if it's out in a major area where you don't have roadways or things to use? Well, then you can do things like traffic cones. You can do caution tape. There's a whole lot of things you can do to visually indicate, but it has to be something that's automatically visible to everybody to make sure that it's very clear. Now, that first in team can actually do their initial isolation zones. They can, if they know the information or the specific chemical, they can look up what is recommended for that specific chemical to isolate and then the protection zones. If they don't, then they can go ahead and say, if it's a solid, use 75 feet. If it's a liquid, use 150. And if it's a gas, use 330. And that way we can actually come in and already have some initial isolation in place and people moving away from the specific spill, and we can come in and deal with that in a safe manner. And then increase, decrease, change, modify zones as we go based upon our risk assessment. Now, you remember in your emergency response guidebook that we have the picture that shows us the area of the spill, and our initial isolation zone will go in all directions. So because spills can have some backward movement and some upwards and sideways movement, we want to make sure that our initial isolation zone is all the way around the spill. And then we'll use our protective action zones in the wind directions. So that way we're erring on the side of safety, upwind and downwind. But when we're doing our risk assessment, the things that we need to consider that are going to affect our control zone size and shape and the changing of it are going to be the chemical and physical properties of the product, if known. So we're going to measure all of these things, right? So radioactivity, flammability, toxicity, corrosivity, reactivity, all things that we can figure out pretty quickly. The state of the product, is it a solid? Is it a liquid? If it's a liquid, is it vapor forming or non-vapor forming? Or is it a gas? And then the container, what type of container is it in? That's going to tell us the maximum extent of the leak. What is the damage assessment? Is the spill up above, or is the breach over halfway above? That's going to minimize how much comes out, right? Or is the breach in the bottom of the container, meaning that if we can't move that container, we may lose the whole load. And trying to figure out all of these different things and how they affect the size and shape of what we're doing. That in turn will then be affected by topography. So we're looking at where we have different things, atmospheric conditions, if it's vapor forming especially, to make sure that we have temperature, humidity, and wind direction followed, and making sure that we then know, are there areas where we might have environmental concerns? Are there areas where we have open waterways that might actually hold some of the ammonia down longer than we would see if it were just in an area with no waterways? The extent of the release, life safety issues, all of these things have to come into play, and they're the things that drive the dynamic nature of our control zones. So I put in a couple of different approaches here that we've used in the past. And so the first one and the easiest one for everybody to recognize is the toxicity-based approach. And in this case, we use levels that are established for worker exposure standards. So in this case, permissible exposure limit from OSHA, or the recommended exposure limit from NIOSH, in lieu of having a permissible exposure limit. And then the IDLH, the immediately dangerous to life and health. If we're below permissible exposure limit, then we know that if we were subjected to that chemical concentration for up to 8 hours, 5 days a week, we would have negligible health effects. And so that's where we set our cold zone. It's at a level that it's still there. It still may be a nuisance, but we know that long-term not going to be a problem. So we'll call that the cold zone. And if we're above that permissible exposure limit, but below the immediately dangerous to life and health, it's kind of the area where we always say, hey, you need respiratory protection. It could be an air purifying respirator or a powered air purifying respirator, but that's the area we're going to call the warm zone. That's where we're going to start decreasing our concentrations coming out of the hot zone through decontamination before we go into the cold zone. And then, of course, when we get above IDLH, that's generally considered a 30-minute exposure for inhalation. And we're going to say SCBA is required once we reach that immediate IDLH level. And that's where we say we have a hot zone. And so while all of these are based upon respiratory protection levels, that means that we're always erring on the side of safety for our dermal toxicity. So for instance, I may use 35 parts per million down here for my cold zone to warm zone, and that's a respiratory protection issue. When I'm really looking at dermal exposure, because I'm wearing my SCBA already, reality is dermal exposure for something like ammonia doesn't even start to become a consideration until 10,000 parts per million. So you have a huge erring on the side of safety in case of wind direction change, things of that nature. Now, if we did a corrosivity approach, we have to first look at the chemical and say, is it vapor forming or is it non-vapor forming? If it's vapor forming, then we just revert back to a toxicity-based approach, because vapor forming liquids actually have permissible exposure limits in IDLH values. So in this case, use the same thing we did for toxicity. But if it's non-vapor forming, do we even need a hot zone? Okay, for non-vapor forming corrosives, there's little threat outside of that exact area of the spill, right? Except for when we're using certain work practices. So we may have a work practice that says we're going to neutralize this and we're going to use something like a sodium bicarb. If we're using a carbonate, then we know when we start to neutralize, we're going to have splattering from the production of carbon dioxide underneath that layer of the mixture. So that ends up causing these gas bubbles to come up and send material splattering. So we may need to increase our space of caution, because we don't want anybody to get splattered with what could be something at a higher or lower pH. And so now we have to start thinking about, do we even need a hot zone? And if so, what are the levels? And I'm going to leave that and let Gary Sharp talk about that a little bit more. On the flammability approach, it's another one that we often see used, especially for chemicals that flammability is their highest threat. And in this case, so think something like propane, something like butane, all of these types of things. Yes, do they have toxicity? Absolutely. But what's going to bite you first is the flammability. So we need to make sure that we have our zone set. And one thing I wanted to make sure everybody was aware of is our cold, warm, and hot zones are way down here in this too little fuel to ignite area. We're not going to be way up in this flammable range already. We're going to be using percentages of that lower explosive limit. So when we say the cold zone is less than 1% of LEL, we've got a lot of movement to go before we ever could have reached a flammable mixture. But this is what will save us from having a complete flashover. If we get up into this area up here where the flammability range is increased, then we could very well find ourselves in a compromised position that we really can't salvage ourselves from. Because remember, unlike a flash fire that you see, a flashover in a fire context, we have a large amount of gases that may be present here, and it's going to burn until all of those gases are consumed. So if we have a continuous release of propane or butane or one of those things, we could have a longer than expected flashover condition. So generally, most people use 10% LEL, so 10% of the lower explosive limit, as the marcation for their hot zone. Then they use less than 1% as cold zone. And that leaves us with the 1 to 10% area in between being the warm zone. And it's about making sure we keep all of that level up above, and then make sure we're ensuring always that we err on the side of safety. The last one I want to talk about is also another toxicity-based approach, but it's based upon radioactive materials instead of chemical threats. And in this case, I just chose to use the public exposure limits, where we use the 2 millirem per hour as the demarcation between cold and warm zone, and a 10 millirem per hour for the warm to hot zone. And what that does for me is at the cold zone, we could have 50 hours in that zone before we reached our annual dose. Whereas up in the warm and hot zone, we'd have 10 hours to that do not exceed dose. So what we're doing here is just looking at the different levels of exposure we may incur, looking at how they affect the body, and then saying, here are the ways that I'm going to always err on the side of safety. And this way, when you set up something that has a numerical way of doing it, where you can defend it based upon toxicological endpoints, it allows you to have a defensible approach to everything, where you can really give people out the information you need. And just a reminder that obvious visual indicators are your best friend when it comes to setting your zones. So use things like physical boundaries if you can. Buildings, roads. On the road, you can use guardrails, signs, highway, the lines on the highways, trees. And you can also add indicators. So I like these little LED road flares. You can get them in all different colors, and you can set your zones that way. So you have an LED strobe beacon. You can also use things like just regular traffic cones or caution tape. But all of that can help you with designating your zones. And just remember, it's very often that your zones are not these beautiful little concentric circles. Your zones are going to be in the flow of the material. Whether that material be in a solid, liquid, or gas phase, we have to see where it's going to move and how, and then set our zones accordingly. So there's a lot of approaches that we can use, but we have to set them all based upon a thorough risk assessment. We should always document the process and then communicate those results. That's the first thing that we should be doing as we set up incident command in a hazmat context. Risk assessment, documentation, communication, and then where possible, visibly mark those zones. Remembering that your important considerations are always going to be the personnel and community safety, then the incident characteristics, and then minimizing the spread of contamination. Okay, where possible, use your detection and monitoring capabilities to continuously assess the incident and make sure that your tactical measures are making it smaller versus larger. And with that, I think I'm going to turn it back over to Rick, and then we'll go to Gary, I believe. Thanks, guys.
Hello.
You want to
You got to repeat that. I was doing tech support.
Okay. Well, you bring up the slides there, Rick. I'll start driving for me. I'm going to mention a couple things while you're pulling that up. This is kind of a soapbox issue that over the last couple of years that I've spent a lot of time on, both public protective actions as well as setting up some of these initial isolation zones. In addition to some of the hot, warm, cold stuff, but really we've been focusing a ton at the initial zones. I'm fortunate, after spending about 15 years full time on the fire department. When I left to do hazmat teaching full time, they let me stay on the hazmat team, and so the guys on the hazmat team become my guinea pigs. Everything that we're thinking about trying out, you try it at home first and do it in a little lab, and if it makes sense, you can kind of take it on the road. But one of the drills that we've been doing for a little while, just on these initial isolation distance and public protective action, is even started with the technicians and then pushing it down to the ops folks, was just challenging them to commit to a number. Right? Here's the incident, particularly transportation stuff, because highway cargo tanks and rail cars, and just asking them, if you got here first to this, how big of the zone would you establish? And what we saw is there's actually quite a bit of hesitation amongst even the technicians, let alone some of the ops folks, to just commit to what are we going to pick. And a good little drill that you can do, I've been buying these little toy tank trucks on eBay, and they're great because they're super replicas all the way down to the little placard. They're 1/64 scale when you just kind of go on eBay and put diecast tank truck or rail car HO scale or 1/64. But you throw that on the table and give the folks an ERG, and you can tip it over a little bit. Some guys are getting crazy and putting cotton balls next to them for plumes, but you put a handful of those up and then ask folks to go around with an ERG and just commit to a number. And it's pretty enlightening to see the amount of waffling, because if you look close enough, obviously you can see a container shape. If you look a little closer, you've got a placard or a UN number, and they've got different information. They got to go to a couple different places and trying to decide on what's that initial isolation distance. And then when you start adding in protective action distance, or ask them if it's on fire or not, and all of a sudden that number changes from 330 feet, and you got to be the guy to say everybody within a half mile evacuates. It's real easy to do on a tabletop, but there's a tremendous amount of hesitation, I think, in the street for folks to be the guy that picks the number, right? You don't want to overdo it and have the name Chicken Little the rest of your hazmat career, and you don't want to underdo it and get somebody hurt. So if we look at the next slide, something like this, I just picked the tank truck. The good news is when there's a vapor cloud there, people tend to, if you can see a cloud, firemen know that cloud's probably not conducive with their pension, right? They start stopping short. They automatically start making a little bit of zones a little bit. If you can give us the next slide, Rick Emery.
I don't have any more slides. That's it. There was only one slide there.
Okay, well, I'll just talk through it then. We'll figure out where the other 6 went. So once you go to the ERG, you got a couple options, right? There's, when you're setting this initial isolation distance, there's the container shape. And the good news is, this one's a great curveball because this specific container, right, this FRPs, it's not in the ERG. But it doesn't matter whether you end up picking the 307 or the 407, 312, 412, they end up taking you the exact same guide number. If you do get a look at the placard, you can see that it's a black and white corrosive. It's going to take you to a different guide number. They're all going to give you the same, almost the exact same guidance, right? A couple things I wanted to hit on here, though, on this initial isolation distance that gets set up. Christina alluded that it doesn't have to be round. I found it's way easier to make it just square, right? Particularly that if you buy your Fireline tape in 300-foot rolls, right? It's self-measuring when you got to set up a big one. You can hook it to something. It might end up being a rhombus or something, right? But if you can get 4 Fireline tapes around this and they're 300 feet, you somehow have some semblance of a 300-foot shape around it. And if you're just getting the people out of there, that initial isolation zone, if the first 2 companies can just chase the people out of there, if they can't go, they get rescued. If they won't go, they get arrested. But either way, they got to go, right? Then no one's going to get hurt if we've moved them out from around there. And I think we just underestimate how difficult, time-consuming, an effort that takes. The protective action distance, I'll leave for another day, but I got a whole tangent after, we had, Paulsboro, New Jersey, 2017, our community had a large pipeline break. And, gas transmission line really struggled to identify what the isolation zones were. Multiple agencies, it wasn't until what actually happened is the dispatcher got on Facebook and took a little map and drew a map with their finger, don't go here, posted it on Facebook, and it became the official incident map of all the responding agencies. And we knew then we had some work to do on setting protective action distances, but that's for another day. To kind of give you a preview, the next slide, Rick. We found is if you do get some of these bigger ones, and next slide, I think I hit that. In addition to just getting it, in the street, when you're just trying to, it really, I think, helps to get it on a map. I mean, it's one thing to be out there trying to measure this off, but when you're really trying to get your arms around the totality of the circumstances, and if you jump to the next slide, whether you draw those on a paper map or you jump into some software, it doesn't have to be a full plume, right? Like what's the PSI and the pressure and how big's the hole kind of stuff. This is just a circle of 330 feet, and the software happens to add in the wind for you. So you can see what the downwind, this one goes through and it picks out all the locations that are downwind for you. But just drawing a 330-foot circle on the map really helps to give you an idea on Google Earth, something like that, really how big the impact area is, and help identify what those zones need to look like in the street. I'm going to pause here and let somebody else take it.
Okay. Anybody on the panel have anything they want to add to this one? And I'm looking at questions in the chat as well. My question for you, Gary, is why did you make the source the hotel you put me at when I taught there?
Right. I should have put you downwind, right?
Thank you. All right. Is that it for yours, Gary?
Yes, sir.
All right. So we're having technical difficulties. Jeff Zentek will be up next. But I can get it to go. All right, you should be seeing Jeff's example.
There we go. Can you hear me okay?
Yes, I can. Thank you.
Okay. So this is an incident we were on several years ago where 2 people had died from being in a confined space, which was venting hydrogen sulfide. So, when Rick talked to me about doing this, he wanted some sort of toxic to go with this. And obviously, this is, to me, one of the most toxic gases around that we don't really pay much attention to because we think of it being so simple. It's sewer gas, it's hydrogen sulfide, no big deal. Well, if it's no big deal, why would it be classified in a fire diamond as a 440, right? So it's a huge concern to us. The good thing is about it is it gives us indicators because it's such a strong smelling product. However, after about 120 parts per million, we get that olfactory breakdown, and then all of a sudden we think it's gone. So what we had in this situation is we had two gentlemen in this vault below ground, but we were getting over 200 parts per million at the entrance. Okay, so this is in August. Obviously, we know H2S, its properties indicate that it's going to hang low, but being that it's 110 degrees out, it's going to gain that kinetic energy, and obviously it came up like it did. So what's the problem with that at 200 parts per million at the opening? Well, the problem is that's twice the IDLH. So one of the things we immediately had to do is develop a hot zone for us. And this is our nomenclature. We develop a hot zone. We can't really develop an exclusion zone in this, even though we'd like to, but because we have to operate inside here. So what we did is we tried, because this is such a compact incident for the most part, we make this area that we're going to work in, which we're going to do monitoring, we're going to do rope rescue operations, we're going to do retrieval using a high point, plus we have to have people there to assist getting bodies out of the opening. We need a lot of people working in this area. However, we don't like the atmosphere it's causing because it's so high in its IDLH. So what we had to do is we had to set up this hot zone that was big enough to accompany all that, but small enough to where, because our meters tell us as we're getting further out, it's not as bad. But we're going to be operating in this, and there was a strict policy that once anybody crossed that tape, they had to be in proper PPE. They had to be in either turnouts in SCBA, or they had to be dressed in what we were dressing people in is level B, because the people that were going inside were going to encounter a lot of muck and stuff on the walls, and we didn't feel that was a good job to get that on the turnouts. So we had people in different levels of PPE, and if they were operating inside this kind of compact hot zone, they had to be full PPE, CPC, and breathing air. The other zone we might call our code zone, is we spread it out large because we had to keep the public out because of what we were going to do, which I'll tell you in a minute. Plus, we had to keep the media out because it was a very high profile event that was happening. And what we had to do is we had to evacuate a bunch of cars, a bunch of people, and get this so we can operate in here. So the third thing we had to do is, in order to provide a proper environment for them to work in, because we're not only dealing with a toxic gas, we're dealing with a flammable gas. If we know the properties of H2S, it's toxic and flammable. However, it's toxic way before it's flammable, but that, in our opinion, that doesn't matter. They're both bad. So what we had to do is we had to set up a fan, and the properties tell us that we're going to put this fan on exhaust. Sometimes people would put it on supply, and I'm not going to go into a ventilation profile on this, but we decided to do an exhaust on this, which is going to pull those heavy gases out and push them into an area where we don't want them and push it away from where we're operating. So that's our third, and this would be called our exclusion zone, because there is no reason for anybody to be in this exclusion zone. And as you see, that was marked by the yellow areas right there. And Dr. Baxter indicated that visual indicators are good to use. And in this case, I thought they were excellent because we had basically a compact a compact incident compared to like what Gary was saying, where you have much more ground to cover to try and figure out those zones. So the problem with setting this up, though, is, and I don't know how we could get more involved with this. I mean, cones wouldn't have done it. Tape apparently didn't do it. But next slide, Rick. We found out that these people right here decided to have their little chat of what they were going to do inside our exclusion zone. They actually got in there behind our back. We weren't paying attention because we were focused on what was happening over here. And I turn around and I see these 3 people in our exclusion zone. I thought that a visual indicator of caution tape meant everybody stays out, but it not necessarily does that. So in addition to putting up our exclusion zone and our visual indicators, we have to monitor that and make sure nobody decides to go in there and do some business. And actually, I had to walk over there and tell them to exit, which they did after some concern when I told them that the stuff we're venting into this area is the stuff that killed the 2 people in the hull. I had to get that basic with them. Another reason, and going back to where our initial hot zone was, that circle, the other reason we did that is operating in that area, we have a hazard that's below ground. So we're defining this area and we're putting physical tape up because I know this sounds very unlikely, but I would never say never, but there's always a possibility someone's not paying attention and they walk into that hole. So in other words, anybody coming into this area, this hot zone, needs to have their head screwed on straight, needs to be in proper PPE, needs to be aware of their surroundings. And any questions from the panel about this? I hope I didn't. I think I used too much time, but oh well.
No, so Jeff, I think it's really straightforward on this one because you had not only a physical barrier of the hole, but you also were monitoring to make sure that it was obvious if things changed. And that monitoring and detection is what is critical to any of us being able to make this work. And setting zones based upon IDLH and things of that nature, I think is a good thing because it is toxicologically based. It's something that we can define and we know errs on the side of safety. So, I mean, that was a pretty cool call. But yeah, it would be interesting to see how to do that in a major city environment.
Right, and the nice thing about it for us is we have the manpower to do this. We're continually monitoring. We're not only monitoring around the hole, in the hole, but we're monitoring downwind when we're pushing all these deadly gases off. But it did not stop some people. We call them the looky-loos or the blue canaries of having their little meeting in that area. I would have thought that that was something that would have never happened. But again, you have to always have your eyes on what's going on, even if you think you've got it set. That's why setting up non-visual indicators is tough. I mean, it's really tough. It's the only thing you can do sometimes because of the wide area that you have, such as what Gary said. But man, you gotta really be looking at what's happening around you. Because you turn around and next thing you know, you've got a group of people walking through, and you know. That's
actually why I love the little beacons, because they're LEDs. You can get red, yellow, and green, and you can put them out, and most people know red, don't go. Yellow, use caution. Green, you're good. So that's kind of where I was going with the images of those, because they're just LED flares, but without the flare issue that we could have that would have a flammability problem.
You haven't lived till you've had an officer throw one of those flares in the ditch and light the joint up. All right, so I've got Mike Callan on. We're going to go to Mike Monaco first, and we're going to slip Mike Callan back at the end. And that actually now I have Mike Callan on twice. So that'll be double the fun. But Mike Monaco, you want to go ahead with yours real quick?
Sure, sure. And I just wanted to do a quick comment on Jeff. I think we often forget sometimes that, you know, when we put up like a yellow caution tape, everybody who's responding and working on scene, they're used to being on the other side of that yellow caution tape, right? Like, we don't think of us as being like, oh, I'm not supposed to cross that. Like, I am supposed to cross that as a normal firefighter, as a police officer, so on and so forth. To have different colors for your tape, you know, like to have a red hazmat hazard for your hot zone or your exclusion zone or something like that, that lets somebody know like, hey, yeah, even though I'm part of this scene, this is not an area that I should go. But we can't even get civilians to stay behind the yellow tape. So,
Well, Mike, I can chime in on that, Mike. That's a great point. And we have actually 3 separate types of tape. We've got yellow, we've got red and white, and we've got red and black. Red and black is our exclusion, no entry even by hazmat personnel. The problem is that what we discovered is that people were not abiding by that because they didn't have yellow tape. So they go, I'll just put up red and black tape. I get it. It's going to keep the people out, but that's not, you know, it's what it's doing is it's reinforcing bad behavior.
what if we just put out landmine signs?
Yes.
You know,
yes.
Just caution, landmines ahead.
I've actually ignored those before, so I'm just going to step out of that conversation.
I'm not surprised in any way, shape, or form.
Thanks for bringing that up, Mike.
Either.
No problem. I was tasked to talk a little bit about ammonia and some of the ammonia runs that we've had and how we've set up zones. And where I work is a very densely populated city, and it adds a whole nother complexity, almost a complexity and then almost a simplicity to setting up these different zones, your hot zone, your exclusion zone, your warm zone, however you want to pronounce it. We kind of go off the cuff and we don't really have a set thing that we say. But with the advent of the buildings that we have in our area, that really changes how our first 2 units, how our technicians, and how the operation gets set up for these zones. And a lot of times we end up doing a lot more sheltering in place because of the buildings, because of the nature of, you know, I can't evacuate half mile of Manhattan. Like, it's just not going to happen. So we take them into consideration, but more to the fact of like, okay, I need to be using my meters. We're going to do a lot of the toxicity approach, where we're turning around and we're going, okay, we need to know what these levels are in certain areas so we can determine whether or not I need to evacuate this area or whether we're going to shelter in place, and then have the manpower to continuously monitor those areas to make sure that our decisions aren't changing. And this happens in our city in a 3-dimensional, you know, point of view too, where not only do we have to worry about going out, but we have to worry about going up. And especially when we're talking about something like ammonia, which we've had several pretty big ammonia incidents in the city when it comes with refrigeration. One of them was out in the middle of a park, and it was at nighttime and everything was hanging low. So we didn't really have that 3-dimensional up type of a situation to deal with, but we did have that the isolation distances around the skating rink that we really had to deal with. And we actually found it the opposite of what you would normally think, where the people wanted to stay so far back that it would have hindered our operation versus actually coming forward. And the reason for that is the odor threshold for ammonia is less than 1 part per million. Where the IDLH of ammonia is about 100, and then your PEL is around 25 parts per million. So to get people to get the operation to want to move closer when it comes to ammonia often tends to be the opposite of, like, you know, what Jeff had, where people are kind of diving into the situation. So we tend to use our toxicity, we tend to use our meters to justify moving the zones closer, where we turn around and we say, no, listen, I get it. You smell it. It's really strong, but we can't have the command post 3 miles away. We can't have the staging area 7 blocks away. I can't be walking from here to there and you expect me to have any air left to be able to operate. And, you know, I need my support structure closer. So in situations like ammonia, we are using those numbers to justify getting a little bit closer. And then a lot of times the buildings themselves end up being our physical barriers. So we will do quick checks with our meters, and ammonia is a really kind of an easier one to do because it picks up on our PID, right? We get great hits on our PID for ammonia. Quite oftentimes we'll even toss away our multi-gases and we'll just carry around our standalone PIDs. When we have a situation where we have 3 dimensions, it becomes really easy to start to implement the other operations level trained personnel to use a PID to help establish zones, to help make sure that the evacuations are being evacuated properly, and that the people above the incident are either sheltering in place or leaving based upon those numbers. So ammonia is a really straightforward one for us. We find out what the PID readings are. We generally are not worried about flammability outside of the hot zone because you're talking 15% of the atmosphere before we reach our lower explosive limit. Anybody who's worried about burning is going to be long dead before they actually ignite. So that's not too much of a concern. And then really the biggest issue, if we're not dealing with a building that's holding in the vapors, starts to become where are we setting up our command post, and trying to get them in the right spot can be critical. I would prefer to come in and set up, figure out where the plume or the vapors are going, and I want to try to set up 180 degrees from that from that wind position, especially in the city, especially when you have buildings around, because the winds change extraordinarily quickly and extraordinarily rapidly. And generally, I'm not going to get a 180-degree turn in the wind. So I know at the very least my command post is going to never be affected by wind changes, or if the situation suddenly gets worse. Now, when it comes to ammonia and your warm zone or your decontamination zone, this becomes a little bit tricky, not in the beginning, but more towards the end of the operation, where you actually have people that were in the hot zone that are extremely contaminated with ammonia vapors, and now they're stepping out, right? Because originally we were like, okay, here's the zones. We're looking, all right, we're at 25 parts per million. We're less than 25 parts per million. We're good to go. Okay, the people working in the decon area, they're going to implement PAPRs because we're below the IDLH. We can meter, we can monitor, all that happy stuff that goes along with a PAPR. We can turn around, put them there. Generally, we're going to do a fan style decon for ammonia. So that lends to 2 things. The people coming out are now massively off-gassing ammonia. So where is that going to go in relation to the cold zone or the operations, the command post? And then what are those levels going to become when the personnel come out of the building? So the people that are performing the decon, are they now going to be in an area that is now above the IDLH because of the off-gassing of the suits? Not such a big deal when we talk about an outdoor operation, but if we are in a building and we have to do our decon inside of our building, that does become an issue because now I'm trapping vapor inside a room or inside a hallway. So when it comes to the exclusion zones, we use our meters and we understand the fluidity that is involved with our zones, and how a zone can suddenly change, how one thing could first have a 25 parts per million and then something happens and we now have to include that as part of the hot zone, or we need to expand the warm zone. We need to push back or bring in, contract and expand our zones as the situation changes. So with ammonia going up, we would take units, we would go above. We had an ice cream store that was leaking in the middle of Brooklyn, and it was surrounded by 6-story multiple dwellings. And we literally had to make sure that the exhaust from this system was included in those zones. What is happening above us, going to various apartments, making sure that there were not any kind of readings, and any readings that were, we either isolated that apartment based, closing windows and seeing if we could get the readings down, or we would just go ahead and evacuate. So from an ammonia point of view, that's how we generally tend to set our zones. They're very fluid. As a result of the fluidity, it's hard to set up exact defined areas. And we'll try to do it with more manpower and gear, right? Where we turn around and we say, okay, here's the decon zone, don't pass the decon zone. And since that is generally in line, you have your command post, your decon zone, and then your hot zone, people from the command post aren't going past that decontamination point.
Question for you, Mike.
Yes.
On your meters, are you generally sticking to PEL, IDLH, and that for your numbers? Are you going a little lower than that? Did I lose them? Did I lose everybody?
It looks like he just froze.
Looks like you all just froze. Maybe Mike didn't hear me.
I can see, oh, Mike just, his head moved a little bit.
Okay, I'm here.
There.
Did you hear my question, Mike? I don't
Okay,
think you
there we
did.
go. Now I hear you now. I did not
Okay.
hear the question.
The question was, are you generally sticking to things like PELs, IDLH on your meters to make decisions, cutting them a little lower than that? What do you use in your IDLH for hot zone maybe, and PEL for cold?
Yeah, generally we're looking at PEL and lower for cold. Anything between PEL and IDLH, we're going to start to look towards the, that's where we're going to be doing our contamination or our warm zone. And we're going to, again, because of that off-gassing effect in the decon area, we're going to try to shift that to the lower part of that limit as much as possible, so that we don't inadvertently enter the IDLH area. But yes, for the most part, we're looking at our IDLH is 100 for our hot zones, or the potential for that to happen, right? We're always trying to also think ahead, especially inside of a building, right? I go to a skating rink and the ammonia is at the bottom of a skyscraper in Manhattan. I need to be thinking about vent paths. I need to be thinking about what is going to happen if this gets shut down or this gets shut down. Where, could my situation expand out as I'm trying to make it better? So not only are we looking at what it is in the moment, but I need to try to predict what could happen in the future. And I want to include those in my isolation distance, in my hot zone, so that there's never a problem where the situation expands and somebody accidentally gets hurt.
Definitely want the boss to know this could be moving.
Yes.
Any other questions from the panel?
I just have a comment that I would say for 99% of the country, very rarely do we have to consider doing the zones within the building, in the decon within the building. But when you think about it from your perspective, coming out of the building might actually take more air than you have. And I was like, oh dear God, you just threw a loop to me I hadn't even thought about.
It's
thanks, Mike.
No problem. That's what I try to do. I try to screw up people's day. It makes me very happy. But no, it is. So I am very good at it. And it is something that we definitely take into account when we are dealing with some of the larger buildings in Manhattan. Really, before we do anything, understanding the ventilation system of that building starts to become a real issue. And even to the point where we are like, all right, well, how does that ventilation tie into the elevator system, right? If I shut down or I have this ventilation system on, is that going to impact the elevators? Because the elevators are going to bring product up and down the building. So the three-dimensional point of view really starts to throw some loops into the equation.
Even your HVAC inlets, intake, have to be considered.
Oh, sure. Or other buildings intakes.
Right. That's what I mean.
For the same regard that you wouldn't want to park your apparatus in front of an intake of a hospital building.
Anybody ever done that?
Yeah, a few times. And you want to make sure that you're not deconning next to something that's going to intake. So yeah, there's definitely a lot that goes into creating those systems within a densely populated area.
Did you know that when you have an ammonia leak in a building and you set up PPV and they're combustion engine PPEs, PPVs, you basically replace the ammonia with carbon monoxide. And that ain't good in a hotel either.
No.
All right. We're going to hit Bobby Salveson, and then with chlorine, and then we'll loop back to Mike Callen on his incident. So Bobby, you have the floor.
Can you hear me?
Yes, sir.
All right. I'm just going to let this thing play. It's around a 5-minute video. I'm going to kind of condense the nonsense. This, for those of you that guys remember this, this is from August 4th of 2002, a place called DPC Enterprises in Festus, Missouri, and they released 48,000 pounds of chlorine. So I just want to kind of set the stage on this thing. They had an emergency system. What really happened was they installed the wrong hose. Right, so they would use these rail cars to fill up smaller containers for light industry or whatever it might be, and they installed the wrong hose. They put a stainless steel hose on where they were supposed to put this hose that was called like Hastelloy. And if I'm putting the wrong emphasis on the wrong syllable, I don't know, but it was something like Hastelloy. And eventually the thing popped and broke. All right, and so a couple of things here are kind of unique about this thing. As far as our control zones, just discussing in broad terms the chemical and physical properties of the stuff, we have a PEL, aka our SCBA, goes on at 1 part per million. Very, very low, very toxic. Ideally, it is at 10 parts per million. The technique, and we've discussed this at length, the technique of using a fog spray to knock this down and to put it onto the ground and just have bleach is I'm going to say best case you can use it as a hydraulic push like a fan, but in worst case you are not, the solubility is 0.7. You're not really doing that. So I'll buy it as a pushing agent, fine. Our vapor pressure is 6.8, so it is absolutely a gas. And one of the things that you're seeing in the video right now is this plume that's generating, and you can see the vapor density to keep it really, really low. A couple of tricks of the trade. You see the two guys up on top of the rail car. They obviously made entry into this commodity using a level A suit. And in this scenario, I would wholeheartedly agree with their assessment. I am absolutely against, and I know Mike, I speak for Mike as well, I am absolutely against anybody that says I select my PPE based on my commodity. Like saying that, okay, if you have chlorine, then you have a level A job. I could have, maybe not in this scenario right here, I can say, well, I could put a stack of fans behind me and I can make it shorts and flip-flops. And I'm exaggerating a little bit about that, but don't always think that a commodity equals X. It's not true. One of the things that they're dealing with here, and it looks like they just stopped the leak because it doesn't look like it's coming out anymore, is the expansion ratio. A quick rule of thumb, if you see a cloud, it's usually because it's a liquid leak. The expansion ratio of chlorine is 457 times, 457 gallons per 1 gallon of liquid, right? So a trick, if I'm going up there with my chlorine kit, I can basically drop the bonnet on whichever one is the problem one and attach, let's say, a 100 gallon, 100-foot garden hose to it and put my problem 100 feet away, right? That's one of the tricks. If I had this leak, and this is just me speaking here, if I have a liquid leak, I would seriously consider opening up the vapor lines, because why is it pushing out of there? Because the vapor pressure on the top is so high, pushing it out that hole. If I release the vapor side, there's no push anymore, right? So that would clear up my whole problem. I would advocate for, I mean, obviously, you're going to be, if you see a leak, you have a liquid leak. If you smell a leak or your meters are going off, you have a vapor leak. So when you're making entry into this thing, you are dropping those LED things like Christina was just saying at that certain line, which is going, for this one, it's going to be a huge, huge hot zone, exclusion zone. So what I would do is, because of that distance, because of the probability of me maybe running out of air, maybe needing some type of RIT or fast team, I would absolutely advocate for bringing all my equipment up in a dragging sled or a sked. Not because I'm lazy, which is true in addition, but because that is my RIT team. If I fall down, Mike is going to roll me into that sked, and that is going to be our exit. I would also consider, additional SCBA cylinders or whatever else might be on the way, where if I can get far enough away in that 180-degree removal route, I might be able to hot swap a cylinder, whatever it might be. I'm planning for the worst case. And one thing we haven't really spoke about in these control zones is that an area of refuge, like setting up with the advent of the drone today, we can maybe do an inspection of this scenario and find which is the most effective entrance and exit from our whole thing. And again, because of the vape pressure of this, my decon is going to be a fan. So the longer I'm walking back or towards, actually back to the command post, I am utilizing that whole let chemistry do its chemistry thing, let that gas come off of me and leave. That is a plus. I think that's a good way of doing it. Good.
Yep. This is one of those cases, kind of like the ammonia, where you know where it is. Hopefully you're not smelling it because you're wearing SCBA, but people are telling you where it is.
Yes.
But I was so happy that you mentioned that about solubility, because I don't know how many times I hear people say, we're going to put up a master stream and we're going to knock that right out of the sky. And you hit the nail right on the head there. You are going to move it.
Ammonia works great.
Ammonia's
Chlorine,
fine.
not so much.
Not chlorine, not 0.7. But you're going to move it, and you may not move it where you want to move it. And by the time you figure that out and you realize what a dumbass you are, oh, did I say it out loud? You might not be so happy with where it ends up there. So good. Now, do you meter at all in an incident like that for chlorine?
We would meter to establish zones. And at the point where our mission changes to mitigation, I put down my meter and I pick up a screwdriver. So there's no reason to bring in the meters to a place where I know it. I'm putting on the suit because the meter told me to. There's no reason to do that. I'm blowing up meters.
Exactly. 2.5 times heavier than air, approximately. And the other thing that's phenomenal in that is the tree line. If you watch how when that hits the tree line to the right side of the screen, it really blocked it amazingly. But you'd still have a huge amount on the other side. All right, panel, anybody else have anything to comment on that?
I would just like to say that I think this would have been an evacuation nightmare, perhaps.
Yeah.
I was going to reiterate the thought that you said, Rick. I was going to say I'm so glad you brought up the fact that chlorine is not soluble, and doing water curtains or pushing with fog nozzles, it just creates more of a mess. But the other thing you have to consider is when you're doing downwind evacuations, how are you dressing your people? Do you have enough people to do this? If you're going to employ PD to do this, are they going to be properly suited?
Nope.
So I think you're talking getting companies out just to do evacuations and to be in the proper PPE. And like Bobby said, or when you're dealing with chlorine, it's not necessarily level A. You're not going to evacuate in level A costumes. You're going to be doing it in turnouts, but you do need SCBAs, and I think that's an important point. So when you see something like this, you better start calling all your cavalry to come, because you're going to need a lot of people,
It's really important to remember that dermally, chlorine doesn't really start to cause burns on the skin until you reach about 10,000 parts per million, which is 1% hydrochloric acid on the skin. So think about it in that perspective. What is the percentage of hydrochloric acid that's going to interact with your skin? And that's what chlorine's becoming with the sweat on your skin. Right. And so you do have a huge factor of safety here. So at those levels farther away, turnout gear and SCBA followed by proper decontamination is a really suitable thing. We have to remember, though, that turnout gear, as we come in closer and get higher levels, specifically with chlorine, chlorinated materials can affect the longevity of the fibers in your turnout gear. Yep. And that's something that we want to make sure that we don't do if we can have other things. So could we have something like, hey, paint overspray garments? So if you have Nomex coveralls that you might wear when you're painting hydrants, that might be a more suitable than your turnout gear if you have to come in any closer, just because we don't want to affect the long-term fiber strength of our turnout gear with chlorine. Thanks.
I can remember back in the day when there was a very large jar of Vaseline on the rig, and there were no level A suits. So the Vaseline on the rig, Mike Monaco, went under the armpits and the groin. So you could do a 1-ton container leak in your turnout gear without hurting yourself too bad.
Thank God
can be
times
done.
have changed.
Well,
And there
the
will be
horse
no
is-
Vaseline in hazmat calls anymore.
Well,
There's a
horse is
photo
really
floating
moving
around somewhere of Chris Wire, who made a level B chlorine entry, took a chlorine meter, but they carried it in the bucket, and they didn't realize the battery died as they were carrying it in. So he went in level B. By the time he came out in the decon and he took the suit off, it bleached all the blue out of his uniform, and it actually turned it pink. And so I don't know, we have an official record of what level it was, but we've got a pretty good photo of Chris wearing all pink after the
Well,
chlorine
and frankly,
flew out
you'll
of his
know
uniform.
right quick with both chlorine and with ammonia. For the gentlemen, you'll know, and you all know what I'm talking about, where I'm talking about, but your first indicator of chlorine and ammonia exposure is going to come from your friends down below. And you'll know it. And we'll all know it because you'll be dropping drawers so fast on a hazmat call that we'll be washing you down with a little bit of a giggle inside. Sometimes the giggle will come out.
let me ask a quick question. If so let's say, this was in a place in the South, it's a hot day, you're tasked to evacuate an area, 10,000 parts per million until we worry about skin contact. Is it unreasonable to be like, you know what, I'm going to forego my bunker gear altogether and I'm just going to do this operation in work duty uniform and SCBA?
It depends on how far out you are. And I mean, I would not want to go above PEL but really when they're doing those evacuations, they're farther out. If you just go back and look at something like the South Carolina Graniteville, a lot of those people that were civilians coming in for decon and evacuation were self coming in. And you're going to see that. And reality is they were self coming in, and most of them, the decon's going to be air anyway.
Right.
So reality is we're going to try to do as much as we can without having to go into something. But as your lower levels, you want to really be focused in on having your gas phase and making sure it stays gas phase. It's when you start sweating more and more that you have that ability for it to become a solution, and a solution will stay in contact with your skin much longer and cause problems. So we don't want to get up towards that point where we know we have skin problems. And remember, down below for the boys, it's going to be well below 10,000 parts per million when it starts interacting with the scrotum. It's going to be up higher when you're talking about dermal tissue at the stomach and things. But you're
First of
talking
all,
a
I don't
14
think I've
times
ever heard you
difference
do a
in
speech without
permeation.
using the word scrotum.
I just wanted to say scrotum. You're
You
right.
like to say it.
It's every presentation I slide it on in there because it makes me smile. So
Jeff made a really good point, though. Every time we do one of these tabletops or talk to people, they say, well, we're going to call the police and they're going to do the evacuation. And that's not realistic because they don't have the gear. And when they say, well, they have, gas masks, your CS gas mask is going to help you a whole lot when you're in that concentration of chlorine. So it's not really realistic in my view.
Well, and if we nerd out about really, public protective actions on evacuate versus shelter, right? There's, I think there's a couple big decision points on evacuating tends really to be for flammables and explosives, right? You can't shelter when your house is on fire. And you really have the option on toxics to shelter in place. And there's a lot of good case studies, particularly, Minot, North Dakota, multiple cars of ammonia released simultaneously. Everybody that sheltered inside was fine. Only the people that went outside. Houston's great ammonia case study of the 331 that fell off the overpass. But particularly on this one, when you look at, can you stop the leak or not? And the good news is, when I compare this versus Graniteville, the car's torn open, right? You're never stopping that leak. That's a long running leak. People can't shelter for long periods of time. When you really start looking at this, a chlorine release when it's coming from the valve area, even if you don't have the kit, if you open the vapor valves, you can put the car in auto refrigeration. And quite honestly, this car leaked. There's excess flow valves on the liquid valves. Part of the reason, in addition to the hose breaking, it leaked because the liquid line wasn't fully open. So, you know, you could do the Top Gun of I'm going to bring them in closer, right? By opening the valve fully so that the liquid valve would seat. But I think in this one, if I knew it was particularly from the valve area, I feel really good about our way by hook or by crook stopping or slowing the leak. I'd be very different if this thing's derailed and torn open and you have a huge release. And I'm thinking that car is going to be there open for days. Let it auto refrigerate, wait for the largest cloud to pass, and then move to evacuations. But I said I wasn't going to nerd out about public protective actions, and I did it anyway. So I'm going to stop so I don't take up Mike's time.
But good point, Gary. You know, I always equated that to the first in engine. Do you put out the fire or do you evacuate 200 people from an apartment building? And sometimes putting out the fire is the right answer. All right. So any other comments? We've got Mike Callan coming up. There he is. So Mike's going to do a flammable for us. Go ahead, Mike. You have to unmute. You're going to need to unmute. You're going to need to click on the little white microphone looking thing to unmute.
Okay.
There you are. Okay, go ahead.
Slides.
Now you're going to want me to do that, aren't you? Jeez,
No,
it's not easy.
I've got mine now. I'm just asking. Mine are up there. What do I need to do to make them come up?
I have to get them out for you.
No. I have my own.
Oh, you sent me slides.
Yes. But I also have mine just in case you didn't have them. There you go.
I think it's easier if I do them, just out of curiosity.
Go ahead. Click. All right. Some of you will recognize it, but you have to understand what it was to live this. And I wasn't in Phoenix. But what I want to say is that the real key for me was that this changed me a lot in terms of how I looked at zones. And what I mean by that is, you go ahead and give me a click. And why don't you give me 2 more clicks to make it speed it up? That's good. Toluene for us was something we saw a lot of because I work in a lot of plastics where I come from. But what I want you to understand is that when I saw this happening, and this was the old, when you see this video, it's the old Dave Lesak video, grainy, but it made a lot of difference to me simply because it was one of those things about setting up zones is where I come up with the statement I use a lot is where you stand directly affects your perception of the emergency. The guy in the tank was dead. The guy that was helping the cutter was killed. If I'm pretty much sure that was the case, if Jeff might know for sure, if I misspeak myself, let me know. But
hey, Mike, we have a real bad echo coming. Do you have 2 mics open by any chance? You had 2.
I may. Let me just look at it.
Is anybody else hearing that echo?
No, it's probably.
Yes.
How about now?
Better.
All right. The other part of this is that bothered me is that any firefighter that looks at that slide right away is going to think one word. He's going to say flammable. Now give me another click. Now can you hear me?
Perfectly.
Yep.
Okay, good. That's what bothers me, is that we never see that it's just not one color. In fact, if you click again, I'll show you what I mean. Is that when we look you hear me say it all the time, there are 3 things when we're dealing with a flammable when we go to a call. There's no way around it. We're dealing with what's the oxygen concentration, what's the flammable concentration, and what's the toxic concentration. And the reason I say this is if I have 21% oxygen, I can have a fire. If I had 35% oxygen or if I had 10% oxygen, things begin to change. And that's where we're standing. Because the only way I'm going to get low oxygen is that this toluene has leaked inside the container and they're going into the container. So what I try to do with this slide is I say the first thing, give me 2 clicks, Rich. is that 1% in the air for me is what I call street smart delineation between the world of toxicity and the world of flammability. You're going to measure below 1% in the air lots of parts per million. And if you go above 1% in the air, you're going to start seeing flammable ranges. In fact, if you go way up in flammable ranges and you start using another concept, is that when you get mathematically, and I'm not saying you bet your life on mathematics, but around 7.1, 7.5% chemical in air, give me a click, is enough to drive oxygen below 19.5%. So just by the nature of physics, high concentrations we know lower our oxygen. One more click. So I have my three worlds. I have my toxic world, flammable world, and oxygen deficient world. I know they like their meters and they grab their meters. So one of the things about meters is, let's look at toluene. Toluene, if you look at my 1%, and this is why I like to use toluene in this example, is 1.3% of toluene is 10% of the LEL. Okay. Or its lower explosive limit is 1.3%, excuse me. So the flammable range is right about what you're looking at, because the flammable range of toluene is 1.3 to 7%. If you say, okay, well, where do they set their zones up? They set their zone up as 10% of the LEL. So if it's 10% of the LEL, and we know that 1% is the LEL, then we're looking at about 1,000 parts per million for 10%. And I usually say, would you agree? And they go, yeah. Okay, now I don't draw that in there, but the reason I didn't is if 1,000 parts per million or 1%, 1,000 parts per million is 10% of the LEL, I would suggest to them, if I go below 10% of the LEL, what is it? And a lot of them want to use the word safe. And I said, it's not safe, because that 500 is important to me, because 500 is toluene's ideal H. So when you think about it, you use the word safe on the grounds, and I do it, see it all the time. What does a firefighter do when you utter the word safe? And in the audience, they'll reach for their face and they'll do this. And I'll say, you're exactly right. And that's the problem. So when you take all of this together, for me, you can't just look at a chemical for the placard. You have to consider the world of setting up your zones, is that you've got multiple zones sitting on top of each other at different points. And so if you go towards that tank, you're going to have a problem. Now give me another click. So there it is again. And this is what I try to leave them with, is now if I give me 2 clicks, flammable, one more click, toxic. That's the worlds that we deal with. And they know that up in the other end is oxygen deficient, but now we're dealing with flammable. So you can take this to the bank. You can bet on it. And I've heard of 3 people say it, is that give me a click. Inhalation, give me another click. Comes before flammable. There's only 4 chemicals that this doesn't work for. Methane, ethane, acetylene, and I've forgotten the 4th one. Methane, or natural gas, that's how I look at it. Hydrogen, that's it, hydrogen. Everything else is going to be toxic. Those are only asphyxiants. I can guarantee you if it's a flammable liquid, it's toxic. There's no doubt about it. It's got a PEL, and if that concentration rises and we keep getting closer to the leak, give me one more click. Now I deal with energy, and now I'll go back to Phoenix. I left that Phoenix event studying it over and over again and trying to figure out how I would do it. I'd have made the same cut. I'd have made the cut because I came from a rural area sometimes, and if you had a guy trapped in a silo, the way you got him out was you cut the sides of the silo where you think he is, so you can get them out. It was a logical thing. I could see it. And I understood the idea of water because we all believed if we kept water on it, nothing would happen. We came away from that incident with enormous amounts of lessons that somebody had to die for. And we should have figured it out, because now the other thing that I tell everybody is energy is always dangerous. So I leave you with this thought. Give me one more click. Where you stand directly affects your perception of the emergencies. All these things we've been talking about are just creating zones, but we call them hot, warm, and cold. Most of you guys know me. If I put a meter in somebody's hand, I'm only going to ask them 3 questions if they get a reading. And the 3 questions are, give me a click, Rick. Is that meter telling you it's safe, unsafe, or dangerous? And they should be able to know that before all the things you guys have been talking about. PELs, IDLHs. Look, you know you got a problem in class when a guy comes up to tell you and says, what's IDLH? What? He said, what's IDLH? I had another guy come up to me once and said, hey, I think I got it, but I don't know what the ideal H is. Is that hydrogen? And I said, no, I'm saying ideal H. So they don't get it sometimes, but you know, I was listening. I got to leave you with this thought. There's things that you guys are talking about that, like, a lot of us experienced because that's all we had. We maybe had 4 books at the time. But what we did find out was that every time something happened, we begged, borrowed, or stealed that slide or that videotape because that was all we had. And that made a big difference because we could share that information quickly. We do it a lot more now. Heck, I go on there now and I find great pictures of things I wish I had 20 years ago, simply because somebody's already got a camera. It was rare that we had cameras back then. So what we do, I'm pleased. I actually, I was listening to you guys and I'm going, wow. I know this sounds stupid, but we've come a long way from where we were back in the 70s, is to say, you know, we really did it. The only thing I'm proud of, and I'll leave you with this, the first class I went to Rockville in '83, Frank Dosum and I taught one class that we're proud of. It was called Detectors, What to Do After Your Nose Falls Off. And where we've come now to where we were then is a big difference. That's it for me.
I have to get back to where I can see everybody.
I have to say, for while you're getting everything up, this has been just kind of, I mean, I think it's a really cool concept that we just did here. You've got people like Rick and Callan that have been here since before any of us ever thought about, well, frankly, Rick was doing hazmat when I was a toddler, okay? And I start looking at that and think, now we've got Mike Monaco. I mean, you've got Jeff and I who are retired, but you've got Bobby Salveson, Mike Monaco, Gary Sharp, these guys that are still active in making the differences for the future. And so I feel like we've come from all of us in the past and handing it off to these guys in the future and listening to them talk, knowing that the future is safe because we have guys like them coming up. And that's really what we've been trying to do in the hazmat community for the last 10 years, is find that next generation that's going to take it the rest of the way. And I just want to thank you guys for really being here and being part of it all and being willing to keep going with it, because,
You know, Chris,
we're getting old.
Christy, when you say, you know, you got to find these guys, Rick, it's been a John Eversole week.
Yeah.
And you think about John, Rick, how many times would he say, you think you want to sit out there? I don't want you to sit out there. I want you to come up here, find me, say you want to teach a class, and I'll make sure you teach a class next year.
It's true.
It's a full contact sport from John Eversole.
Yeah, I think back to the first days of Rockville and that, and we have come a long way. But John and I used to laugh because, boy, we were on the road a lot teaching classes together. And we used to laugh because we said, all of our examples are bad. Everything we show you is what not to do. I just remember I probably have 1,000 videotapes in my basement on a wall, like behind Christina there on
We
rack.
don't want to know, Rick. We don't want to know.
They're all hazmat.
Oh,
And John used to say, he goes, man,
With
we killed
Vaseline?
23 firefighters in our class, but we didn't show anything correct or right. And then some of the programs started to be developed, and with the partnerships we made with people from the conferences and friends and that, and we started to go from everything's negative, what not to do, is we started to teach how's the right way to do it. And Bobby had to jump off here for a minute to go pick up his son at school, but I think it's critical. And this format, shameless plug, is a lot what the hazmat guys do with Mike and Bobby, bringing in, another person or two to talk. But I would love to do more of these with 6, 7, 8 people and just do these round robins. Like Mike Callen would remember back in wherever we were, Pooks Hill, when we used to do the curbside sessions that were they were great as an instructor because you didn't have to come up with a program. You went in with a couple questions to get the juices flowing, and then everybody started throwing stuff around, and it was really just a facilitated discussion. So maybe we got to do more of these at some of the conferences around. What do you think?
Well, my first guy, Socrates, that's how he did it.
He was your chief, right?
No, he was a lieutenant then. He was a lieutenant then.
Well, speaking of the people who bathe in the oral tradition, they, and I'll do a shameless plug on our end, not to plug anything, but to actually get people to understand the passion that we have to get your experiences audio archived for the next generation, right?
Yeah.
Like for those of you that have been in firehouses and are firefighters, how much have you learned sitting around the table, hearing what people did and hearing how people screwed up? And, like, hey, it was 3 o'clock in the morning and I had a flipped over tanker and stupidly I reached up and I opened the cap and it all poured out on me. Like, those things are so important to do, and to get people to take their experiences and audio archive them and have them accessible for generations to listen to, on top of the fact that we were talking about this with Rick the other day, the generation that was there did that, and there's a reason, like the rule is there because of you. We need to know how that came about, right? We are so deep right now into just the meters and the technology and the explosion of meter technology that we're losing that fundamental as to like why we're doing what we're doing. And I don't want the next generation to have to relearn the mistakes of what has already happened because they've veered away and gone so deep into technology and meters that the operations have suffered. And the reason that we do what we do is now gone. So if I could just iterate to anybody listening, and if you want to pass on the word, please, your experiences matter. Reach out to me, Mike at the Hazmat Guys. We'll set up a time to conference. We don't need names. We don't need departments. We just need actions, thoughts, and lessons learned. And that's all I have to add.
Thank God we didn't have cell phones back then.
yeah.
Oh, I know that.
I want to add that, people often laugh at all of us because we get together the first Tuesday of every month to just chat hazmat stuff. So the first Tuesday night of every month at 9 p.m. Eastern time, there's a bunch of people that are online, and we send texts back and forth, and we're all flying and having a good time. And people are like, you've been doing this your whole career. Why do you still get on to these chats? Because I learn something every time. Yeah. And the minute we stop learning, we might as well hang it up.
Right.
And so it's really important for people who are interested in hazmat to understand that the Hazmat Guys Roundtable is every month, first Tuesday, 9 p.m. You can get onto it through YouTube, through Facebook, through all kinds of the websites. And I'm not on it. I'm just the crazy girl in the background sending these guys texts saying, hey, Mike, do this.
Yeah.
And he does it.
Oh, I will. The thing about it is that the moment you want to be on it, and anybody from the community wants to be on it, you just have to click a link and come on.
Yeah.
Like we are nothing more than just what we're trying to just be is a mouthpiece for the community, and that pivoting point of learning and information flow. So even if your first hazmat run, you learned something, God damn it, come on, do a podcast, come on to the round table, share. And even if you're on your last run or you're thinking about things that you did, just come on and share, audio archive it, and make sure that generations from now, people will be learning from your mistakes and experiences.
And you get to see Jeff Zintek's hair.
Which is phenomenal.
Yeah, it's there. It's still, he's
Who
even
wouldn't wanna
retired
see
and
that?
it's still there. So it's an added bonus for everybody.
I've broken many a screens trying to put my hand and tussle his locks.
Okay,
Me too.
now you're veering off.
Yeah.
All right, it is 2:31 by my clock. I can't thank you guys enough. When we came up with this idea and Christine and I talked about it, this is exactly what we envisioned. So appreciate it greatly. I hope and this was a large crowd on this, everybody got something out of it. If nothing else, go back and start thinking about how do I set up my hazard control zones. You don't have to do it the way I do it or the way these people do it, but you got to come up with a system in a way that you do it consistently so you're safe and your members are safe.
Yeah.
Enough said. Thanks, everybody. I appreciate it. And the next session starts at 3 o'clock with the computer program. So that'll be interesting. And that's a long one. That's going to be a 2-hour job. Thank you,
Calvin,
everybody.
thanks for joining us.
Yeah.
Thank you.
Bye,
Goodbye,
guys.
folks.